So we talked about naming binary ionic compounds. Now we're going to talk about naming compounds with polyatomic ions. Again, you're going to have this list with you of all the polyatomic ions you're going to need to use and their charges. So the charges are the main thing. So if we start with this formula, we're going to go from formula to name first. Okay, formula to name first. Step number one is still, mess that up. Step number one is still to name cation. Now, in the previous video, we talked about binary. I said just name the metal. Well, the metal is always the cation because it makes the positive charge. In this case, we have a couple of polyatomic ions that can be written first. So technically, they're not metals, they are cations. So we're going to name the cation as is, whatever it is. So in this case, it's aluminum. Okay. So aluminum is our cation. Again, subscripts don't matter. All right. Subscripts don't change naming, again, just like in the last video. All right. And then step number two. Name the anion. All right. There's a couple of ways to do this. Okay. If it's a polyatomic ion, it as is. Right? If it's a phosphate ion, say phosphate. If it's a phosphite ion, say phosphite. And there is a difference. Okay? If it's a non-metal, okay, these rules. Okay, that's and IDE. Okay, so we're going to look at some examples of each one. Okay, so step number one is to name the cation, and then step number two is to name the anion. Now, in this case, our anion is SO4, so it's a polyatomic ion, so we're going to name it as is, and SO4 is sulfate. Okay, so we have aluminum already. All right, and then SO4 is sulfate, so aluminum sulfate is your answer. Okay, so let's look at one. Let's look at just another example here. Let's go magnesium. That right there. Okay. You're going to name the cation. So that's magnesium. Okay. That's your cation. And then you're going to name the anion, which in this case, again, is a polyatomic ion. So we're going to name it as is. NO3 is nitrate. We're just going to call it nitrate. So magnesium nitrate is your answer. Another example. So in this example, now we have in this example we don't have just a metal. Okay, so you're going to have to be able to identify and look at something and go, okay, there's no metal there. What is the cation? So in this case, the cation is this polyatomic ion here. So we're going to name it just as is. NH4 is ammonium. So we're going to name it ammonium. We're going to write that down. That's our cation. All right, and then we're going to name our anion. Okay, PO3 is phosphite. Down phosphite because that's our anion. So our name here is ammonium phosphite. So in this case, we've gotten two polyatomic ions, one there and one there, and we've combined them into one compound. Let's look at one more example. Let's go with ammonium again. So NH4, all right, and then let's just add a regular non-metal to it. Let's go with Cl. So NH4Cl. So again, you have to be able to identify that that's a polyatomic ion, and then here's our non-metal. So step number one, we're going to name our cation. And it's ammonium. Right, and then we're going to name our anion. Now, this is not a polyatomic ion here. Right? It's just a regular non-metal. So we're going to go back and go, okay, well, if it's a non-metal, we're going to use the previous rules, right, from the previous video. So we're going to take its root, chlor, okay, root, then we're going to add IDE to it. So ammonium chloride is the name of this one. Okay, so let's talk about going from formula now. Okay, name the formula. So let's say we have example. We'll take lithium nitrate. Okay, so step one, all right, is to write the chemical symbols for both, just like in the last video. Write the chemical symbols for both. So we have Li, all right, and then you're going to look up on your list of polyatomic ions, and you're going to see that nitrate is NO3. Okay, step number two is the same. We could really combine these, okay, but it's going to be to add the charges. Li is a plus because it's in the first column. NO3 is a -1 because that's what's on your list, and that's what it tells you it is. All right, and then step number three is the exact same. You're going to cross the charges to make subscripts. That'll be. Okay, so we're going to take our charges here. There's a +1 and a -1. Right, and we're going to cross them down. That creates Li. Okay, we took our -1. Because it's a 1, we're not going to write it. And then our NO3. So there's our answer. LiNO3 is lithium nitrate. Okay, now this 3 right here, how come we didn't do anything with this 3? Right? NO3 is nitrate. Okay? So NO3, this whole thing is nitrate. If you change this number, then it is no longer nitrate. Just like if you change the number of protons in something, it's no longer that element. So it's the same kind of process. If this is the polyatomic ion, then that's what it has to be all the time. That's why you saw me putting parentheses around some of them out there, and we'll do a couple of examples like that as well. But the polyatomic ion must stay intact. Okay, it's got to stay together. All right, let's do an example where we're going to use some parentheses. Okay, so let's talk magnesium, and then let's use nitrate again. All right, so in this case, we have magnesium, which if you look on the periodic table, is a 2+ charge. Okay, and then nitrate again, NO3 with a -1 charge. All right, now you're going to take these charges, you cross them down just like we did in the last video. All right, and again, the signs don't matter. Okay, again, signs don't matter. We are only concerned with the numbers. Okay, so we're going to take Mg, and it just has the 1. All right, so we don't have to write anything, and we're going to take NO3. All right, and then here we have, we brought down a 2 here, okay? So we brought down the 2, all right, but you can't just have NO32 because it looks like NO32, like you've got 32 oxygens and 1 nitrogen. So we're going to put a parentheses just around the polyatomic ion, okay? So parentheses separate the polyatomic ion from its subscript. I don't know what just happened. That's not right. Okay, so let's try this again. Parentheses. I don't even know how to spell that right. Parentheses separate polyatomic ion from its subscript. Hang on, I can't write. Parentheses separate the polyatomic ion from its subscript. Okay, so let's do one more example here. Let's go ammonium phosphite. Okay, so ammonium is NH4 plus. Phosphite is PO3, and it has a 3 minus charge. Okay, PO3 with a 3 minus charge. We're going to take these and cross them, just like we always do. All right, and then we have NH4, 3. We're going to put our parentheses around the NH4 to separate it from that 3. All right, and then the phosphite is just PO3. And we brought down a 1 here, so we don't have to write it. Okay, you don't always have to put parentheses around it. You don't have to do that. Okay, so don't think you have to put parentheses around everything. All right. Let's do one more. One more. So let's go. Calcium phosphate. All right, so calcium is a 2 charge. Phosphate is PO4 3 minus. Okay, so those are our 2 ions. All right, we're going to take our 2 and our 3 and cross them down and make the subscripts out of them. So you've got Ca, bring that 3 down. All right, and then PO4, and we've brought this 2 down. So Ca3PO4 is your answer. Okay? And that is naming formulas and writing formulas with polyatomic ions in them.